Good morning, everybody. Well, the time is 10 o'clock, so we are going to get started here. Let me make sure I've got everything going here. Just one quick second. Okay. All right. So my screen should be showing up there shortly for everybody. And let's make sure everything else is all good to go. All right. Well, hey, this is Roger from the Wichita office here. I really appreciate everybody taking the time to join us this morning. I really appreciate and like what the Norman office has done in leading in leading webinars like this. I kind of see it as like a almost like a visual training moment. Randy there at Norman has done a lot of just regular training moments, whether it's a PowerPoint or something. But I really like this idea of just kind of hey, let's all go in the conference room and virtual conference room and chat about an event we worked. The cool thing is doing it this way, we get to involve other offices. So I'm excited about that. Admittedly, I'm a little nervous. It's my first webinar I've ever led before. But today, also, Kelly Butler from our office is tag teaming with me on that. So the way, just real quick, the way we're planning to do it is we'll run through this event here that affected parts of Kansas and Oklahoma about a week and a half ago or so. We're kind of looking at it from two parts. This is an interesting event because severe weather season, convective season always carries uncertainty. There's nothing new or earth-shattering about that. But I think what's interesting and kind of what I wanted to hopefully at the end open up for a little bit of discussion is, we have times where, we have convective allowing models, we have our global and deterministic models and so on, and we have a lot of data out there to use. So from a probabilistic standpoint, there's times where maybe the majority, if not all the models are showing one convective scenario. But this was a unique case where most of the models were showing one scenario, but there were one or two models that were showing a different scenario, which in this case, the outliers, if you will, were showing a scenario that actually would carry a higher impact. So, kind of thinking through as we're kind of stepping through here, if you want to be thinking through, you're working the forecast or you're working on the forecast of the messaging, your office, and you're trying to figure out, what's the best way to message. You want to tell people what the best, the most likely scenario is, but at the same time, you don't want to ignore some of these outliers. A lot of times the outliers don't pan out, but sometimes they do. So anyways, so that's kind of the approach and kind of the motivation behind this particular part of it. And then when I'm done with that, Kelly, she's got some neat radar and satellite stuff that she wanted to run through. So, all right, so we'll get started. And by the way, I want to throw out just again, very informal. There's no, if at any point someone needs to drop off, there's not going to be any nasty grams or hate mail or anything sent to anybody. So, and even at the end when we have a discussion, sometimes we've done these and there's been very little discussion. Sometimes there's been a lot. So even there, if people want to stick around and keep discussing that, feel free. But if you want to drop off, that's fine as well. All right, so let's get started. So let's see here. Oops. Okay, so I wanted to kind of run through as if, think about, put yourself in the position of you're the forecaster. In this particular event, I was the forecaster the day before the event and the day of. So let's, we'll kind of put yourself in my shoes, and I was working the day shift on both of those days. So, all right, so you can come in on July 10th, Friday, that's the day before. Let's, and we'll run through this real quick. I know there's all kinds of stuff we could look at, but to make it simple, basically, looking at the general pattern was, you had a good ridge there of the Southwest U.S., kind of retrograding just a little bit, pretty potent shortwave there moving out of the northern Rockies, rounding the ridge there and moving into the upper Midwest, Great Lakes region. What's notable here is you had some pretty good flow, mid and upper flow for this time of year. So, I mean, that's based on the RAP analysis, you're looking at 40 to maybe even 60 knots there, mid levels, and northwest flow. Bad things can happen, as you all know. So, all right. So, and then with that enhanced flow, so Friday you had effective shear anywhere from 40 to 50 knots, which, I mean, that alone would be good for July. But then the models were forecasting as that shortwave moved into the Great Lakes and that the stronger flow overspread the central and southern plains. Now you're talking 50, maybe even 60 knots effective shear, which is great any time of year. But man, you overlay that in July, and that's a recipe for something significant. All right, we'll take a quick look at the surface analysis here. We've had some in our office that have kind of played around with the PGen tool. I really am a big proponent of hand analysis, but I found the PGen tool and AWIPS can be a nice, you can still put on surface observations and do some virtual hand analysis, if you will. So this is about midday, the day before on Friday, so on the 10th. So that day that started, so when I came in that day, we had some lee troughing there east of the Rockies, kind of a broad zone of warm air convection across most of the plains with some embedded convective clusters there. There was one near the OKC metro, and then there was one there east of Rapid City. All right, so this is just kind of a general, without stepping through every single model for the sake of time. I wanted to just kind of look at just the general overview. So the href ensemble 24-hour QPF mean, just to kind of give an idea of where the models were, where the general trend was as far as the potential convective evolution. So you notice there in the hatched or dashed area, there was kind of a general consensus that something, if we step back here, some of the convection, if you see up there in southeast Montana, that was kind of ahead of the main shortwave that was coming out of the northern Rockies. So the thinking with a lot of the cams was that convection there east of Billings, Montana, would eventually grow upscale, and then you'd have kind of a larger complex that would dive southeast across portions of the northern central plains. And again, you can see that in the mean QPF fields as well. So there was really good agreement on that. And so that was kind of the way that we were kind of messaging it in our office. We were thinking, okay, we're going to be dealing with an MCS in the overnight period, Friday night period, and kind of messaging the severe potential that way. But I wanted to point out here from the outlier standpoint. So this is the 21Z RAP forecast, and this would have been Friday the 10th, so 21Z on the 10th, the day before. What's interesting is, while a lot of the models had some sort of a large MCS cutting south through Nebraska and Kansas, eventually making it into Oklahoma, the RAP that day, when I was doing the forecast, that was one thing that was a little concerning, because the RAP had some convection over the northern plains with that shortwave, but it had nothing over Kansas. So that's something where, again, so how do we best message that? Because you've got most of the guidance, even from an ensemble perspective, saying, okay, this scenario is probably what's going to play out. But then you have the RAP and I believe the SREP as well. Generally tried to downplay the MCS potential. So this was SPC's outlook, which I'll step back. I want to make sure everyone's screens catch up there. But again, this was the href mean, so keep that in mind. And then we'll go back here to the SPC outlook. So they were thinking the same thing, convection developing over eastern Montana, dropping south to the northern and central plains overnight. But reading in between the lines, part of even in their text, they mentioned that there's some variation in the convective allowing guidance. So there's some predictability issues there, but that their thinking was, in line with ours, that some sort of an MCS would be rolling through the plains overnight. And I believe even for this outlook, they'd actually kind of expanded that slight risk southeast into Topeka's area with that expectation. So this was the graphic that we put out on the day shift the day before. Again, we were primarily focused on, MCS coming through with damaging winds, some, marginally severe hail, possible flooding. Ironically, this graphic ended up working really well for where the actual severe weather ended up taking place, but it worked well for the wrong reason. So that was kind of interesting. But we were kind of hitting on, okay, most of the models were showing some sort of MCS moving through Topeka down into eastern Kansas, but then down into Tulsa's area. We kind of left the door open a little bit for some storms there along the 135 corridor. But again, we were mainly hitting on wind and hail and focused on the, overnight into this early Saturday morning period. All right, and then looking ahead to day 2. So on Friday, SPC, this was their outlook for July 11th. And again, same thing. They were thinking there'd be an ongoing MCS early Saturday morning that would eventually increase as it moved into the Ozarks region with heating downstream. So we were kind of, I thought we were, from a local and regional perspective, national perspective, we were all on the same page there. So that part was good. All right, so what actually happened? So let's just take a quick look. Friday night. So 6Z is on the left and 12Z is on the right. So we did, that convection in Montana did move south through the Dakotas and into Nebraska. But notice 12Z, where is the MCS? In fact, where is the convection period? There's, a couple little small clusters there, one near the Wichita metro and then one up in the Twin Cities. But there is no, large MCS, did not happen. And again, keep the RAP in mind because the RAP actually, was showing some of the convection there between Hastings and Des Moines, but it was showing pretty much no convection over Kansas. So here's just the reports overlaid with SPC's outlook, and I want to be clear, this is not a critique of SPC at all. Just wanted you to see where. Just wanted to show that the MCS just didn't happen. You had some pockets of convection there from some of the earlier day storms, but as far as MCS, wide area of wind damage, that did not occur. All right, so now you come in the day of the event. So you come in, you're the forecaster, the midnight shift briefs you or whoever is giving the briefing, and hey, we didn't have an MCS, so now we've got a cold front that's going to be plunging south into an unstable air mass that's not been overturned. What are we going to do about that? So this is the again same kind of thing. This is the noontime period. Again, there's still no convection. A few little storms there in northeast Kansas, but again, no MCS. The air mass was not overturned. I know it's probably a little hard to see there, but on the left, the surface plot there that's showing dew point is what's shaded. The pink is upper 70s to near 80 dew points. So the interesting is, so again, the models were all showing this cold front would be pushing south, but the day before, the general theme was you'd have an MCS rolling through that was going to overturn things, disrupt convergence and ahead of the front. So that we were kind of thinking the front would just come through with not much fanfare. But now you've got a front that's approaching, a very moist, unstable air mass. And on a quick side note, since we have some folks from the Norman office on, it was kind of interesting. And maybe they would have some insight on this later. There was some sort of convective outflow from the overnight stuff, even though there was an MCS or something that had pushed through our area. We noticed that morning. So it seemed to be some sort of residual outflow boundary there across western and central Oklahoma, which I think might have played in a role in some of their widespread convection they dealt with later that day. But there's no real air mass change behind it as far as that goes. So. All right, and so now you're kind of in that mesoanalyst role of okay, well we're not overturned, so what kind of an air mass are we dealing with? Well, 18Z on the left shows anywhere from 4 to 5 grand a cape, You've still got a pretty good cap, especially across southern Kansas. But look, by 2022Z, you're mostly uncapped across the eastern half of Kansas. If the if the RAP meso analysis page is correct, I mean, you've got 5 to 6, maybe even north of 6 grand a cape. I mean, those are some pretty big numbers. We fortunately we did have an observed Lamont sounding that day from 18Z. And what's interesting, so I mean, even comparing, Randy has talked about this a lot about mesoanalysis graphics and things like that, and are great, but it's always good to compare with actual observed data just to kind of do a quick QC. And you got mu cape there of pushing 6 grand, and this is at 18Z. Before we still had several more hours of heating, so it would have been interesting to see like a 21Z observed sounding from Lamont. But still, bottom line, effective shear 40 to 50 knots. You've got effective helicity around 140. So with that northwest flow, even though your low level flow wasn't screaming, you had some good veering with height there. So, and again, for the sake of time, I don't want to focus on too many parameters. So I'll just use the supercell composite as kind of a catch-all. So 18Z on the left, 22Z on the right. So I mean, you had some pretty good values there for any time of year, but by July standards, definitely impressive. I think by the afternoon, that southerly flow kind of increased a little bit, so that probably helped. I think the helicity and increased about 200 or so for parts of eastern Kansas. So, all right. So now you're in this. Okay, what do we do now? Now we've got to really kind of rechange our messaging, not just at the WFO level, but also at the national level. So again, for comparison, SBC's original outlook for the July 11th was, thinking an MCS would be moving through the Ozarks, possibly re-strengthening. Well, that didn't happen. Now you've got a very expansive slight risk and the addition of a pretty good size enhanced risk. So that's for messaging, that was their change. And then looking at our change, we went from, and this is just comparing day shift to day shift. Our midnight shift, Friday night into Saturday morning, did start to kind of make that change, seeing that the MCS wouldn't happen. So, but again, we went from severe weather, through mainly Saturday morning to now we're focusing it in the afternoon. Hail size from quarter to baseball. We upped the wind gust. One of the interesting things there that was cool in this event. So the three of us, it was me and Kelly were working this event, and then one other forecaster in our office, Vanessa, was working as well. And so when I came in, the two of them had already been there. When I came in, we kind of had a powwow. We sat down. We were like, all right, we've got this moist and stable air mass. What are we going to do about the forecast? We probably, 6 grand of cape, 60 knots of shear. We probably shouldn't go out the door with, quarter size hail and 65 mile an hour wind gust. So what should we do? But we wanted to make sure we wanted to give some good lead time, but we also wanted to make sure we were all on the same page, which I thought was a really neat idea. So the three of us, we spent like 30 minutes. We all kind of looked through some things, and then the three of us had a powwow and said, okay, here's what we're going to do. Here's what we're going to do for staffing. Here's what we're going to do for the forecasting. Here's how we're going to split up our duties today. So, there was a pretty significant change that had to take place. And part of that, we actually had a phone call with SPC just to kind of chat and run some ideas by them. And one of the things that they had mentioned was they were going to, for all of their watch products that day, for our area, they were already planning to mention the wind-driven large hail, which I thought was a great idea. So like that little piece there was a collaboration between our office and SBC. So I thought that was a neat, just a little collaboration piece there. So, all right. So what happened? So again, just taking overlaying the reports with SBC's outlook. The entire enhanced area didn't see severe weather, and it was tough because the Wichita Metro did not see any severe weather, and we had been outlooked in the enhanced risk, but we didn't. We agreed with the threat, so it's just one of those cases. Your Metro is outlooked, and it doesn't end up happening. But I mean, that's just the nature of I don't feel bad about that part. I think we messaged the potential, took the science, and said this is what could happen. But what's interesting is, I mean, there was a narrow but intense corridor. I mean, look at all those SIG hail reports from Topeka's area all the way down into Tulsa's area, and then it kind of became more of a wind issue eventually. And then, of course, you have the convection that lit up there over northern Oklahoma and became an issue for the OKC Metro later. Just a few pictures from that event. We had a lot of hail, some giant hail up in Topeka's area and in our area, and then eventually kind of transitioned to some significant wind damage as well. So hail up to 4.5 inches, damaged vehicles, significant tree, and some structural damage. So yeah, so that was the forecasting part of it. And again, I'm going to toss it over to Kelly here in just a minute, but just be thinking through if there's some thoughts on how to message that, especially again when I did my AFD that day, I focused mostly on the MCS potential. I think I threw in one sentence for well, if the MCS doesn't verify, then we might have a few severe storms that pop up ahead of the cold front. But I didn't mention any potential hazards or anything. So there's something where I wish I had maybe hit the at least touched on the outlier scenario a little bit more, especially given the significant severe potential if the outlier were to happen, which of course is what happened. So anyways, that's something to think about, and if we have time, hopefully we can have a little discussion on that and how you or your offices handle some of those changes. So all right, so I'm going to toss it over to Kelly because she has some neat stuff to show as far as radar and satellites. Let me switch it over to her real quick.
Hey everyone.
Okay.
Can you see my slides?
Yep. Go. It's all yours, Kelly. Go for it.
All right. Hey everyone. I'm Kelly Butler from Wichita office, as Roger mentioned. I'm kind of just going to be going over our warning philosophy that day, as well as some interesting satellite and radar features. So given the environment being as loaded as it was, as well as seeing the reports coming out of Topeka's area just north of our CWA border there, we knew that we had a little bit better environment that these storms were going to be coming into and developing in. So we were really proactive in putting out SIG hail tags with the initial warnings that came in. And actually, we issued 10 total warnings for the events, and 7 of them had at least a SIG hail tag when they were first put out. And eventually, every warning had a SIG hail tag. So here's the first, second, and third warnings of the day. So our first one is for 4-inch hail, the second one for 2-inch, and the third for 3-inch. And something interesting I just kind of wanted to point out is, I mean, these looked like monster storms, and especially the first one, like they had been getting 4 and 3.5-inch hail just to the north, kept it going. But we didn't really get any reports with it, which is a little bit concerning. And the second one here, we got inch and a quarter. And it's starting to, all right, what's going on? Like, how come we're not getting reports here? So as the radar operator, maybe you're saying, oh well, maybe we're just underperforming a little bit from what we have on radar, down here. But even though that didn't make sense given the environment, I kind of stuck with it for at least one more warning. And then I learned a lesson, which is, the environment supports it. So, just because you're not getting reports doesn't mean it's not happening. So since I wasn't really getting my SIG reports and those, those big bombs you'll see in a second, when the newer storms were starting, they were a little bit slower. There was a little bit of mergers going on. So maybe they weren't actually looking that great as to need a SIG hail report, SIG hail tag right away. But they were upgraded like as soon as I saw like, okay, these are exploding. So here's two examples. These two are severe 117 and 18. They were the main two that kind of captured a lot of the baseballs and the 4-inch hail. And as you can see, the times, I started at 1.5 inch and 1 inch, because really early, there was like a half an hour time stamp, between these two before the storms really got going. And then we started getting all the reports of, 2.75 inch hail, bunch of baseballs, and we actually didn't get the 4-inch report real time, which is kind of just a reminder, like, don't let your guard down just because you're not getting reports, because it's probably still happening. And luckily we had a designated, dedicated storm chaser who was kind of lagging behind the storms a bit and kind of collecting hail, behind the storm after it fell, which was nice because it gave us a lot of extra reports and confidence in what we're doing. So here's just kind of a closer map of what kind of reports we had that day. The blue dots with the zeros, that's just storm damage. So some of the pictures that Roger showed there. And then all the red dots are hail and green dots are gust. So I don't see the 70 on here. They're not all listed, but pretty much most of these red dots here, most of them were baseballs. And then we had our 1 4-incher right there. But as you can see, like up here, 1.25, we had 1 SIG hail right here near Chanute of 2.5. But you'll see in a moment, like the first really, really big storms kind of tracked through these two counties here. And we really didn't get much SIG reports. But we also have to remember there's not a lot of population over here either. So just one of those things, like maybe we didn't get reports because of that. So hopefully you can see these GIFs okay. Hopefully they're going good. I have a lot of eye candy in this section, so if you get bored, I'm really sorry, but I think it's really cool. So these are two sandwich product loops. They have a couple of different color curves. I kind of just wanted to run stuff through both with satellite and radar just so you guys can understand kind of what we were dealing with. It wasn't, I would say it was pretty manageable, despite having a bunch of SIG reports come in, like storm-wise, there was really only like 3 or 4 to keep track of, which was kind of nice, compared to what Norman had to deal with that mess down there. But you can see a lot of good signatures on here, and I'll go over them here in a minute, but you can see kind of your convergent flow, where storms might track. You have a couple of anvil cirrus plumes. They kind of see near the end here. So it'll be pretty interesting. So I have 4 different timestamps here, kind of beginning and midway through the event, and kind of just trying to see what could we pick out, during the event that will help us. Okay, where are storms going to form? Where are these going to track? And pretty early on, you can see a couple of things on here. You got some convergent lines here, differential heating over here. You got your front over here, and just seeing where stuff's focusing. And it actually turned out that the 3 main, I guess, bodies of supercells, they followed each of these lines, which was pretty fun. This 2156 one in general painted the best picture of what happened. So just kind of what we could have picked out there. Okay, and then moving forward to a little bit later in the event, sun's starting to come down a little bit, so we can pick out those cirrus plumes. So I don't know if you can see it. I tried to play with a color curve a little bit to try to get a contour in here. It didn't work that well, but if you can see these little yellow, cooler cloud top areas, I mean, those are the start of some anvil plumes. You can see a really defined leftover one right here. Hopefully you can see my cursor. And then you can see them really well, like in this GIF here. They're coming out. I mean, almost every one of these storms, I assume, had one. It's just hard to see earlier in the daylight. But toward, sunset, they can become pretty pronounced. And, there's one on basically each one of these. And I'm sure you all know, but, AACPs, if you're already going to be warning severe and you see it has one, just go ahead and slap a 2-inch tag on it because it's probably happening. And that was based off some other research that we were reading from earlier this year. Okay, so here are some more loops. This is just a radar reflectivity of the entire event. So as you can see, there's not a ton of storms at a time to keep track of, which was really nice. But some interesting features you can key out is, most of them when they got mature had that, V notch going on back here. There's a lot of little mergers coming in here. And now the storms that were on, the eastern edge, they stayed a little bit more separated after they got going. The storms that were kind of in this Wilson area, which is where that big hail occurred, you had mergers that made around right here, made it a little bit complicated for the polygonology, just because you think this one's going to become severe, but it gets eaten by that one, such and such. But we really didn't have too much of an issue with the polygonology. It worked out pretty well. We didn't have any major left splits or anything to deal with, which was really nice. So here's a full loop of the mesh for the event, and it did an okay job, but it did underestimate the areas that, right in this area again where we had all the baseballs and the 4-inch hails, it only had up to barely into the 2-inch mark for that whole area. And I really do think there probably was some very large hail up in here. We just didn't get any reports. And interestingly, down to this southeast corner of Labette, you can see that they really blow up like, what is that, like 2.5 to 3-inch hail down here. We didn't really get that down here. We got, I think, only one report of a 2-inch hailstone right in the corner here in Chitopa. But these areas really is where we got most of the wind. So I'm guessing those were just related to microbursts from all that stuff falling out. And oh yeah, I kept some put the storm reports back on here so you can see. It did a pretty good job over here with the I should say less severe of the day storms, but those storms were also the ones that were a little bit right next to each other rather than having their own environment to deal with. The other loop I have for the whole event is the vertically integrated ice. I think this is my favorite product. I just think it looks cool. There's a whole bunch of ice up there with some of these storms. To get no SIG reports of hail up here, I was really shocked. And as they come down here, you can see 2 of the different storms, max out whatever the color curve is on here, which was pretty interesting. I'm only at year 2 of severe warning, but that was the first time I saw that. So I was surprised not to get anything, a big stone out of that. And interestingly, the, little baby Wilson over here puts out 4-inch stones. So it was kind of an interesting one to watch. So I wanted to focus just on the 2240 to 2300 UTC. So this again is that Wilson area. And it's also where a lot of that severe wind damage occurred down here in Labette. So it's kind of a twofer. So I really want to thank the satellite image is pretty interesting. So for the southeast storm, a lot of pulsing going on a little bit, but some of those storm top cloud top cooling temperatures were like almost like minus 90 C or something ridiculous way down there. And also there's a feature here that one of my other coworkers, I think Chris Jacob, pointed out with previous storms in the past that just look at this swirl in this, it's a clockwise swirl. Interesting that the updraft top kind of does. Not sure if that means anything or if that's coming attractions for something, but pretty interesting. But you see the cloud top cool warms like significantly as we get closer to the end of the loop here. And so that's probably, all the stuff falling out of this storm and causing that severe wind damage down there in Labette County. So I'm trying to nail that 4-inch hail report. So here's 2310 UTC. This is about the time. Again, it's not exact since someone was following the storm in a car to not get hailed on. So it's an estimate, but I mean, we gotta agree mesh was, pretty underdone, only giving a 1.5 to barely a 2 in this whole area when there was widespread baseballs and isolated 4-inch hails. So kind of just really interesting with the radar signature. We were trying to make a little hook echo here down below at 0.5. We're pretty far away from the radar, but there was considerable echo overhang here, which I'll show in a little while. This is also a still satellite to note that that storm was producing an above Vanville cirrus plume at the time. This is at 2311. It's kind of hard to see here with a still image, but you can kind of make it out there. And better so with that Labette storm as well. Okay, so these are two images, one from the Tulsa radar and one from the ICT radar for both storms. So from ICT, Labette, I mean, we're probably, I think we're like 15,000 feet up over here. You can just see just some, massive area of 60 plus dBz in there with that echo notch. And over here, a little bit less impressive looking. But lower, I think this was maybe 5,000 feet from the Tulsa radar. I mean, you can see there's how much overhang is going on in the reflectivity fields. Pretty considerable. And the one thing interesting also is your KDP is pretty high down here with the Labette storms, and maybe we were getting melting of the hail and it really wasn't producing that. But also, I mean, I'm not an expert, but water coated significant hail can also have high KDP, so unclear what was going on there officially.
Hey, Kelly.
Yes.
This is Chris Jacob. If you can go back to that satellite image, I could throw out something that might kind of explain what was going on. Yeah, right there. You notice the difference between the Wilson versus the Labette. You were getting a little bit of anvil seeding down Labette versus the Wilson one up north. You really weren't getting any anvil seeding. That might explain the differences between the capability of producing the hail size. That's something we kind of have been introduced to and we kind of forget, and I think it might have a factor when we're getting into warnings and stuff like that, is kind of looking at that anvil seeding and its possible effects of storm interactions. So I just wanted to throw that out there while it was fresh in our minds.
Yeah, sure, thanks. Yeah, it's definitely interesting, and if that was also going on up here earlier with that same storm, yeah, definitely interesting to look at. So the rest is kind of just eye candy of some of those bigger storms that we didn't get reports of. So I just wanted to show, because I thought some of them were pretty impressive looking. So this is near Iola, Kansas. Again, these are the northeastern storms. I mean, you have a bound to Wichita region, you know, what is that, 20,000 feet. Just, I mean, crazy amounts of reflectivity through there. Near zero ZDR throughout most of the entire column, and pretty low KDP too. And some interesting information is these storms were around 68,000 feet, I think was the echo tops, which was pretty remarkable. And I got some last minute storm top divergence last night calculating, and 211 knots was the winner. Again, these are the storms where we only got in one, like 1.25 inch report. So you got to believe something else was going on in there too. This is just from Erie, Kansas, as the storm moved along south and east. And again, I'm just showing that there's just big stuff up there in Erie. This purples there are like 70 dBz. So just, you know, really considerable weight up there. So you can imagine, you know, if that lets go, we're going to get some significant wind, and which is exactly what happened in Labette. So this is closer to Thayer, Kansas, where the 4-inch hail report came in. So this is about 20 minutes prior to that, kind of just showing like we're really logged all the way up there. What's this, 50 dBz to 50, and kind of a spike here up where the updraft was. And by this is 2309. Part of it's coming down pretty good. It might be a bad cross section also. That's entirely possible. But you can see there's a really strong meso going on here, and pretty low KDP throughout the whole column as well. So it's not surprising that we got a big stone out of that as it was falling out. Later in the event, Oswego, Kansas. So this is another, I have 2 inches from Tulsa, 1 from the ICT. From the Tulsa, I mean, you can just see the really awesome weak echo regions, bounded weak echo regions here. And, you know, a lot of echo overhang right over that Oswego area. And, you know, part of me forgot why I put this section in here, but this is the 2340. Pretty much the last gas of the 2 storms. So this is all going to congeal into one, and this one's going to kind of exit off the rear. But the interesting part was we started to get like really strong rotation in the mid levels with this Labette storm as it was going through this phase, and you can kind of see that's almost you know, a function of, you see the really cold cloud tops, and then they collapse. But you know, maybe that's a reaction to that happening. And I know, I mean, this was much lower here. We didn't put on any tornado warnings or anything for the stuff over here, but really strong, probably the strongest I've seen mid-level rotation that's supporting, you know, supporting something up there. I mean, it takes a lot to host a 3-inch hailstone, I imagine. And then I kind of touched on this earlier, but most of the storms that day in the mid and upper levels, like you had that V notch out in the forward flank of the storm, and I mean, I can't say I know a whole lot about this signature, just that you got a really strong updraft and wide updraft for flow to go around it. But if anybody has any comments on that, feel free to chime in. Some things that I wish I would have had time to look at. I kind of ran out of time doing this, but I would have liked to look at, you know, what the prob severe stuff was again, and as well as lightning jumps. I know when I'm working radar, I really like to have that up. I think it's an awesome feature. Unfortunately, when we did the archive, I couldn't look at it in the west because prob severe wasn't an option. But I know there's a way to get the lightning jump data, but I'm really interested in that in particular. But basically, you know, as an event summary, both Roger and I covered it of, just be more proactive and less reactive when you know the environment supports it and you have the support of your office, and that's the way you're going to handle things that day, whether it's, enhanced messaging, higher impact warnings, and then just a self reminder and a reminder to everybody else that lack of report doesn't mean it's not happening. So that's kind of what I gained out of that. So thank you for attending. And now Roger and I will take any questions or any comments that you all have.
Okay, so hopefully everybody can hear me. Let's see. So what we're going to do is, so I wanted to make quick note here. So it's 10:50. Like I said, if anybody, oh yeah, let me switch over here. Hold on just a second. All right, thanks, Kelly. Okay, so if anybody needs to drop off, like I said, feel free. But I wanted to open up. Again, the beauty of what we've learned from the Norman office and how they've done this is, again, think of it as we're all in a conference room together, just hanging out, chatting about an event. What can we learn from each other? So I'm going to go in and unmute everybody, and hopefully I'm doing this right. So hold on just 1 minute. And like I said, let's have a conversation. And again, if people need to drop off at any point, go for it. I'm on a telework shift today, so so even if we go
with SPC and then sort of translate that into messaging, talking about the wind-driven hail, things like that, I think are really important. And especially just, I don't know, I thought that was, you had an excellent case to show how, you can do really good with the, thinking about it more of in terms of being proactive and anticipating rather than being reactive. Sometimes we just fall into the reactive mode, and we try not to do that, obviously, but I think that's a really good point. And then it's later on, I don't want to dominate or anything, but it's, I do have a question for Kelly here in a little bit. Let other people speak first.
One thing I wanted to throw on about there, just from and I'm not sure this is exactly what happened. Hopefully let me show my screen here real quick. Hope that'll pop up. So, we were looking back at the, what happened the Friday night, the overnight period where we thought there'd be an MCS. There was convection there moving through Nebraska, but then it weakened. But if we go back, and I know it'll take a minute here for it to switch back screen-wise, so bear with me just a second. Okay, so hopefully that'll catch up there. What was interesting is on Friday, so again, the day before, there was the early convection there east of Rapid City. And I guess what was interesting there is like a lot of the models, even the HER, once convection, was picking up on that convection, but it just kept insisting, and a lot of the short-term guidance kept insisting that initial kind of warm air advection-driven storms there would weaken with time. And they didn't. So those storms there east of Rapid City just kept going, and eventually, with daytime heating downstream, they, maybe they were initially kind of elevated or semi-elevated, but then became surface-based and made it all the way into, I think they made it in northern Kansas before weakening. So it's one of those things where, maybe did that factor into that kind of alter the environment a little bit later? I'm not sure, but it seemed like there was some struggle even from the get-go with, that, had that initial convection not been there east of Rapid City, would that have changed the outcome? I'm not sure. So, but anyways, just a quick side note there.
Hey, Roger, along those lines too, I want to go just kind of remind you of the day before when you and I think you guys had Mick on shift that day, and it was Alex on shift down here. We had that conversation about what would happen upstream in your area and how that may impact our area, because I think sometimes we get so focused on our CWA and trying to figure out how things will play out there that we forget that one of the most important parts of the analysis is what's going on upstream. And, I think you guys had that situation with this case, but we had that with the previous day with that elevated convection that developed overnight that ended up producing an MCS that wasn't quite anticipated down into the metro here and produce some wind gusts. So pretty substantial wind gusts at that. And I just wanted to kind of say that, that's just one other big thing with the collaboration aspect of it. And, I think that the more we do that, the better. But that was a good case to show how valuable that was, because you guys give us confidence of what may evolve overnight and how it may impact us the next day.
Randy, I guess a question for you or anyone there at the Norman office. And I apologize again because I'm still new to the webinar thing. So I think I muted everybody, but I think if someone wants to speak like what you did, Randy, I think you have to unmute yourself. I apologize if I messed that up somewhere. But so like your office, for example, do you all have some, how you best handle some of those outlier scenarios where most of the models are saying one scenario and then you've got an outlier that says, well, that's not going to happen, and then the outlier is a higher end or higher impact potential. Any thoughts on that from anyone at your office or even in our office? Wanted to throw that out there.
Yeah, I don't know if anybody wants to kind of talk a little bit more about that from our office, but from my perspective, it seems like there's so many times where we think that we've got a pretty good forecast out, that we know that there's some outlier solutions, and we kind of talk about that. And we say, well, what if this doesn't pan out this way? And we end up in the more outlier solution, and then, end up with a more high impact event. And I think more and more, though, I don't want to speak for all of my staff, some other people that may be on from our office may have a better perspective than I do on this, but I think more and more now we're trying to put that into the AFD or communicate that if there's something we're talking about in operations that could be potentially impactful, even if it's a low probability situation, then that probably needs to go out, at least in some sense, even if it's just a brief mention in the AFD, or maybe some sort of outlier low probability graphic to go along with our deterministic forecast to say, hey, this is probably going to happen this way, but there's a small chance that it could evolve into something more significant, and I think we're doing better with that with time.
Hey, Roger, this is Chris.
Hey, Chris, what you got?
Hey, can you put up that graphic for that messaging where you kind of had that green shaded area and the yellow shaded area?
Yes. Did my screen pop up there for you guys?
Yeah, it did.
Okay, let me get back to that one here. Just one. Go back. Okay, is this the one you're talking about?
Yes, yes.
Okay, yeah, go for it.
I really like this graphic a lot and how you guys created this, because I think this handles that uncertainty, the message uncertainty, in a really clean, creative way, where the green area is highlighting severe weather possible, greatest risk in the yellow. I'm definitely going to use that going forward when we do have some uncertainty, and how to explain that to our end users in a very clean way. I really like how you guys did that.
Well, I appreciate it. Again, the irony with that graphic is, the outlook area ended up being great, but for all the wrong reasons, and not at all, like the timing was off, the impacts were off. So if you scrap everything and just take so anyways, that was kind of a ha-ha moment, like we were right for the wrong reasons. But I appreciate the feedback on that. I think like what Randy said, and then trying to find that best way to message these various potentials, and AFD text products and the graphical products as well. So I think we're all trying to learn together from that. So yeah, thanks for the feedback on that. Randy, you said you had a question for Kelly.
Yeah, it's a little bit more in kind of the deeper meteorology or the radar analysis. I'll be honest, and I'm kind of embarrassed to say this, I have no idea what the vertical. Hey, can you hear me?
Oh, I'm sorry, Randy. I think something happened there. Try that again. Sorry.
No, I was saying I'm kind of embarrassed to admit this, but I'm not. I am totally unfamiliar with the vertically integrated ice, so that caught my attention, and I thought it was really interesting there. That kind of tied in with some of the other analysis and kind of what Chris was saying too about the anvil seating. So I'm gonna have to look at that more, I guess, because to me, maybe with the higher values that it showed for those storms to the southeast that didn't produce the really significant size hail, maybe to me that says that there's just, I don't know anything about the product. Maybe Kelly can kind of clarify a little bit on that, but maybe it's saying there's just a whole lot more ice, and that sort of fits with the KDP signature being a little bit higher, that you just had a lot more smaller hail, smaller in a relative sense, just not 4-inch hail, just a lot more quantity of hail that both the KDP was showing, and maybe whatever this vertically integrated ice product that was so high was kind of hint at that too. And again, all driven by that conceptual model that Chris talked about with the anvil seating. So I thought that was really interesting.
Yeah, thanks for that. I know, I mean, I'm not an expert on it either. I know it's a nice one to look at. A couple years ago, I did the rack course, and they really recommended to have it up, and I've grown to like watching it. But yeah, I had never really seen anything that high. And I know sometimes with the KDP, when the environment is primed for SIG or giant hail, you can have water coated giant hail is also going to give you a really high KDP too. So knowing the environment says, oh yeah, you're probably going to have SIG hail, it's hard to let your foot off the gas, with the warning, when you're not sure. If the environment had been less of a SIG hail, like just a general, 1.5-inch hail, 60 mile an hour, if that was our environment going in, and I saw that, and obviously the integrated ice would probably be way less. But in that scenario, I probably maybe wouldn't even warn on it, because I would say, oh yeah, I probably got a bunch of nickels or less, bunch of melting hail. But I was a little bit unsure in that, and the fact that like you said, there's so much ice. Part of it in my head was, hey, you know what? Maybe this storm is just still lofting all this giant hail. It's just still sitting up there and waiting to come down.
It makes me wonder though, and I want to go back and look at that product now. So thanks for kind of showing that, but I want to maybe kind of compare it with other cases, because it makes me wonder if maybe the really high values of the vertically integrated ice may be an indication that you just have a lot of hail embryos and a lot of just a good mass of hail. And then it seemed to be in this case that was confirmed with the KDP being fairly high, because I know Vivek, one of our forecasters, has really done a good job of sort of showing us how the really high KDP values can be an indication of these accumulating small hail events that we sometimes get.
Yeah.
So it's funny how that just, as soon as I saw that, it really kind of struck with me, and it kind of fit the conceptual model, it seems like, because you think back to some of the research that shows the really strong anvil level flow can be supportive of the big hail, because it can kind of evacuate a lot of the hail embryos down through the anvil, and then you basically are left with fewer stones with unfettered access to super cool water, and you get these really big hailstones out of it. And it tends to be with a more isolated convection. But then the one that was anvil seeded that you showed there, and that kind of Chris pointed out, obviously that process is interrupted a little bit. So I don't know, I thought it was a fascinating case.
Yeah, thanks. Yeah, it'd definitely be interested in looking at just like a SIG hail environment as well, rather than any environment case, and see if we get that same signature.
Yeah, thanks for showing that. Great presentation.
Thanks, Randy.
Yeah, I wanted to just throw out there real quick. I think what Kelly hit on, we've talked about the messaging and trying to, how to best do that ahead of time. And I really, and I'm glad, Kelly, you put that on a summary slide, and underlined it, because I just really think that's really cool. This was a really neat case. I felt very encouraged after this event, because I know I'm biased because it's my office, but the proactive, not just with warnings, but also with the messaging, we Kelly, Vanessa, and I, we had that kind of the three of us sat down and said, hey, the environment says this. What are we going to do? And I remember at one point, I think Kelly had said, well, what if we go like 3 or 4 inch hail? And I was like, I don't know. But, like even I was kind of pushing back on, because, you're kind of, that's some big values to go out with. And of course that ended up happening. And I apologize to her later for hesitating on that. But so even as much as I want to be proactive, even I fall victim to the being hesitant sometimes. But in general, though, I thought it was a neat case of really great example of being proactive. And Kelly, I don't know if you caught that. Kelly was our primary radar operator that day, and again, her first warning out the gate was with sig hail, and warning on we did have some reports there in Topeka's area, but warning on the environment, and I thought from a service standpoint, I thought that was a great call on her part, and so I think that's a neat example. So just wanted to throw that out there.
Hey guys, I just have a few other key takeaways to kind of share with the group here after watching your presentation. Just based off of some of the other research that I've done over the years, just to kind of tie that all together. I noticed, like in this event, and compared to a lot of our other significant hail events that we've seen here in the Central Plains and everything, is a lot of times with these SIG hail events, you will see a strong component for the 500 winds that kind of have that west northwest direction, and this definitely fit that profile. Also tying into something that I've been playing around more with this year and watching and evaluating is that ship parameter that so far for all our significant hail events, it's been 5 for 5 on verifying. So anytime you see values on that ship parameter of 1.5 or higher in the area, the probabilities are pretty high that you're going to see some significant hail reports. So when I kind of tie those two together, that really gets my attention when we're trying to do the forecasting and messaging of what kind of impacts could this storm system or the upcoming storm system produce, and how do I message that. Once we can start seeing these type of indicators, it definitely starts to heighten. Oh, maybe I want to start thinking about potential 2-inch size hail or larger with this event. And then I just have one other thing to add is I know it's probably one of the hardest things we do when you start warning an event and you start issuing the polygons, and we're watching the radar, we're watching the evolution. Another tip to throw out there is kind of tie in that satellite evolution as well. Once you start seeing things develop on radar, always keep in mind that the satellite evolution is going to be ahead of the radar. So if you can see you have a well-developed cell on the radar and it's moving off in a direction, kind of keep an eye on that satellite imagery. Is there some updraft potential developing upstream or in a different direction? That could kind of help you better anticipate how to draw your polygons so you don't have to. So it might help you prevent from getting into these messy overlap situations with the polygon when you can utilize the two together. That's just kind of a thing that I've been trying to play with and want to throw that out there to folks to try and help us clean up our polygons and how to draw it, especially like that back edge, because a lot of times we'll pigeonhole ourselves and it's like, oh no, part of the cell's getting outside my polygon, now I got to reissue. And that's where I think the satellite, looking at the satellite, could kind of help anticipate, maybe I want to extend that box out a little bit to capture this updraft that I see developing on the satellite for future evolution.
Hey, thanks, Chris. And I know one thing I had I think it was like my first slide, and I don't even think I talked about it. So I utilize my hail rack cheat sheet pretty often for environmental indicators, and talking with Roger that morning when we were looking at soundings, I remember just, hey guys, like this is checking off every possible check here. And I know one of the marks for like giant hail, obviously we met everything, as far as shear, cape, lapse rates. But on that one, it's definitely, they don't have a ship parameter for that value, but I mean, obviously anything over 1 for a 2-inch, but they also recognize like the large hail parameter being near or above 8. And that 21Z wrap sounding for the afternoon over southeast Kansas was 18. So I mean, it was blown out of the water. So I know that was kind of what hedged me to be wanting to go that higher option, Roger, for that initial messaging. But I mean, I think what we did, went with baseballs and baseball higher. I mean, baseball was the dominant report pretty much the entire event. So I think it was still a job well done.
And that's awesome that you guys were able to pick up on that and message that ahead of time. I mean, that's wonderful stuff. That's all why we're here. And just to kind of reiterate, instead of just getting focused on these parameters, they're off the charts and everything. They're very useful and everything, obviously. I always want to kind of tie it into what we actually see. What are the actual observations, or what are the models showing? And that's why I want to kind of reiterate that 500 component is when you start seeing large values in the parameters like that, go back and kind of recheck it compared to what is the 500 flow? Does it have stronger wind speeds, and is it more of a westerly northwest component? So when you put those two together, it should build your confidence even more that, hey, I feel pretty good, and my confidence is in, yeah, there you go. You can see the really strong west-northwest flow at 500. When I start seeing that and seeing parameters off the charts, I feel even better going out with a forecast that this has a higher probability of occurring.
Yeah, because we've had some, we've had some other northwest flow events that didn't have that kind of shear. I mean, you had northwest flow, just directional type, from a direction standpoint, but not that magnitude. And for those outside of our office, Chris has really led an important charge in our office of encouraging, what is the synoptic, even before you dive down into some of the mesoscale type stuff, but what is the synoptic setup telling us, what is just that potential. And again, when you deal with not only northwest flow, but anomalous northwest flow or anomalous wind speeds in that northwest flow in July, and unless you're overturned, I mean, that's just a recipe for bad things to happen. So anyways, just a side note about Chris there, as far as I really appreciate the push to look at that again, not just the synoptic, but also the anomaly or the anomalous nature, because that can kind of have an uptick in some of the hazards that we might be looking at. So yeah, thanks for pointing that out, Chris.
Hey, Chris.
Yes.
Hey, I figured if anybody knows this, you probably do, so I'll throw this out there, but if you don't know it, this reminds me, and of course I grew up thinking about, reading lots of books, and of course Coffeyville, Kansas, was it 1979 that held the largest hailstone record for so long? Did you ever go back and look at that event very much? I'm curious because with it being in September, my guess is it may have been one of these, and this is a total guess, but it may have been one of these sort of west-northwesterly flow events or northwesterly flow events.
That is definitely interesting. I didn't go back and look at that, but I would like to. We actually did beat that record. I want to say it was in September 2010 in West Wichita, where we surpassed that. And then we held, I think it was the national record for about 1 week. And then Nebraska, I think Aurora, Nebraska surpassed us 1 week later. and which was kind of crazy. It's like, hey, we had a little claim to fame there, and well, it lasted 1 week, and that was the end of it. But if I remember right, I think that event was also a northwest flow.
It's just interesting that a lot of these record hail events in the plains have been not in April or May, but June, or in a lot of cases, I remember even in Goodland when I worked there that we had a couple softball size hail reports in August and September in these west northwesterly or northwesterly flow events. And it just fits all the conceptual model really well. These are just fascinating events to me, I think. Some of the work that Aaron Johnson did with his publication back in 2014 that talked about the strong shear in the layer above the hail growth zone and the amble layer flow being really strong, and how that can sort of change the trajectory of the hail embryos and that sort of thing. To me, it's just fascinating, but I don't know. If anybody else has any comments or questions to jump in here, but don't let me talk too much. But I was just going to say that it's interesting because kudos to Kelly for, it's not easy to go above the guidance that we have, say mesh, for example, and the fairly large hail that it shows, but to even take it a step further and say the conceptual model or the environment or what I'm seeing on radar says it could be even bigger than that. And I think we're given this excellent calibrated guidance, whether it be MBM for the forecast or whether it be mesh for hail, for large hail, and sort of a good indication of hail size. But the best meteorologist can take all these little small subtle details and observational data and be able to add value to that, to be able to go maybe lower or higher than what this really good solid statistically calibrated guidance can. So kudos to be able to apply those conceptual models and take a risk and step out there and give a better service. I thought that was really excellent.
Thanks, Randy. Appreciate it.